morning, this is your Shalam Sai Krishna. Yes, remaining concepts of the motion chapter, we have to discuss some more basic concepts also we have to cover here. In the last class, we discussed about that distance, displacement, is velocity, speed, acceleration. In the acceleration, positive acceleration and negative acceleration. Yes, again we discussed uniform motion and non-uniform motion. Today just I will forward that some of the practice which of the last class is, and we have to discuss some other concepts of this chapter is uniform motion, non-uniform motion. Once more we have to revise the concepts. Uniform motion, simply we have to remember equal distance, equal time interval. That is also uniform motion. Non-uniform motion, equal distance, unequal time interval. Second one, unequal distance, equal time interval. Third one, unequal distance, unequal time interval. This is non-uniform motion. Uniform motion means only we have to remember always equal distance, equal time interval. Equal time interval, equal distance. That only uniform motion. Remaining thing, everything also, every concept also non-uniform motion. That we have to keep in the mind. Here, motion, types of motion. How many types? We can classify the motion into how many types? Yes, just simply three types. Translatory motion, rotatory motion, oscillatory motion. First one is what? Translatory motion. Second one, rotatory motion. Third one, oscillatory motion. Translatory motion mean what? Translatory motion. Suppose here that one bus is here. Yes, one bus is here. It is moving like this. It is moving on the road, along the road, anyway also. Yes, it is present in which motion? First one. Second one is the blades of the fan. The blades of the fan also rotating. Is like this, the blades of the fan, it's are rotating around these axes. These are present in which motion? Third one is machine in the needle. Yes, needle is up down. Yes, the needle will move up down. Yes. Otherwise, the pendulum is pendulum in the clock, old wall clock. It move as a to fro. The pendulum move as a to fro. Like this only, it should be moved. These three cases. These are example for which situation? The bus is moving along the road and changing its position in every second. Moving. It is in which motion? Translatory motion. Which motion? Translatory motion. Because of in every second, all the object, everything here, tires, this body inside the steering, headlights, whatever it may be, every object, every point of this object is moving, changing its position by every second. That's why this object is present in which motion? Translatory motion. It should be present in which motion? In translatory motion. Yes, here the blades of that fan, ceiling fan, it's revolving around itself. Yes, it is an axis. Around this axis only these are revolving. Are they change its position in every second compared to this bus and these? Is it changing its position? No, always the ceiling fan is present in the fixed position. There is no chance to change its position in every second. But it will be rotated this place only, continuously only. It should be rotating. That's where rotatory motion. Okay, translatory motion, or rotatory motion. Again one, the needle in the machine up down only. Again one, pendulum in the old wall clock is to fro. It should be moved to fro. Yes, that's mean it is present in the oscillatory motion. Oscillatory motion. It is in the translatory motion. It is in the rotatory motion. It is in the oscillatory motion. Yes, try to give some more example for this. Suppose you are walking on the road. Yes, you are running. Yes, along the road you are moving with the bicycle. These all those things are example for translatory motion, because of in every second you are changing your position. In every second you are changing your position. All your body also changing your position. That's why this is an example. These are an example for translatory motion. Rotatory motion. Suppose just you have to take that globe and rotate it. It should be rotate itself only. Yes, always it should be rotate itself only. It's also an example for rotatory motion. Yes. Next one, machine. In middle of the machine is the pendulum. Like that, some other example, swing. The girl's hat in the swing and moving front to back. Again our windows, our doors also close, open. Just that also an example for that oscillatory motion. Here in the translatory motion we have to discuss some other concept. Yes, the bus is X bus is moving in the straight path. Yes, Y bus is moving in the curved path like this only. Yes. X bus is moving in the straight path, there is no change in the direction. Y path is moving is in the curved path. It is in the rectilinear path. It is in a curvilinear path. It is in the rectilinear path. It is in the curvilinear path. It is in the rectilinear path. Because of both also in the translatory motion. But one object is moving in the straight path only. Again one object moving in the curved path only. That's way it is in the translatory motion with rectilinear. It is in a translatory motion with curvilinear path only. We have to remember that is the difference between both also in the translatory motion, but one only moving in the straight path. Again one only moving in the curved path. That's why translatory with rectilinear, translatory with curvilinear. That we have to remember. Suppose you are moving on the road with bicycle. Your motion is always translatory with curvilinear. Yes, translatory with curvilinear. Soldiers are march fasting on the road. Soldiers are march fasting on the road mean translatory with rectilinear. Suppose some boys, they are running on the track. Track mean always like this in the curved way only. So it is an example for translatory and curvilinear. It's not a rectilinear, translatory with the curvilinear only. Like that, so many examples are there. Try to find. Yes, I can forward that practice speech about this concept today itself. You would write the answers in running notes also. That we have to keep in the mind. Suppose drill bit you have to do. Yes, we have to make the holes to the drill bit. At the time the drill will be moving. How it will moving? First it should be rotate around itself and moving inside. First it should be rotating around itself and moving inside only. That's where rotatory motion and translatory motion both also there. Is again earth is moving around the sun. That means first earth it should be rotate itself, and again it should be move around the sun. That means here also again what motions are there? Translatory motion also there, again rotatory motion also there. The drill bit also translatory motion also there, and again rotatory motion also there. Both also present. That we have to keep in the mind. Like that, so many of the examples are there. Try to find the correct answer. Only if it is there translatory motion, you have to write translatory motion. Only if it is there rotatory motion, means you have to write rotatory motion. Sir, both also present means you have to try to write translatory motion and rotatory motion. Suppose you are moving on the road with your bicycle, that means your wheels are present in the rotatory motion. Again your bicycle is moving from one point to another point. That means here the two answers also there, rotatory and translatory. Like that answers you have to try to find. Here one more concept about rotatory motion we have to discuss here. Suppose one object is there, it should be moving around like this, is rotating around like this. Object is here. Object is here, it is in a center point. It is in a center point. While this object is moving around here, at the time, how many forces are working? Any object, if it is moving around itself, otherwise on basis of any center point, this is in a center point, this object is moving continuously. At the time, on this object, two forces will be working. What are those? One only centrifugal forces. Centrifugal forces. Again one only centripetal forces. Centripetal forces. One only centrifugal forces. Again one only centripetal forces. Here some forces are working towards of the center. Some forces are working against to the centers. Here the centrifugal force is lighter particles are pulling away from the center. Pulling away from the center, sending away from the center. The forces which are working to send away the lighter particle away from the center, this is an example for the centrifugal forces. Here the centripetal forces towards of the center, towards of the center, centripetal forces, away from the center, centrifugal forces. The blood samples, the urine samples in the diagnostic center, they can separated by the centrifugal process. We can separate the butter from milk by the which forces? Centrifugal forces only. Precipitate from the chemical reactions, we can separate it by the centrifugal forces. That means lighter particles moving away from the center, moving away from the center. Here the two types of the forces are working. One only towards of the center is centripetal force. Again one only away from the center means centrifugal force. Lighter particles will be comes up. Again heavier particles will be settled down. As your grinder, your mixie is working on basis of the centrifugal forces, because of after grinding the lighter particles will be come up. As heavier particles will be settled to bottom. You have to try to remember. As while your mother working is with a mixie, otherwise grinder, just once you have to try to see lighter particle always should be come up only, heavier particles will be settled to bottom only. That means here which kind of the forces are working? Centrifugal forces are working. Today class concepts related bits also I can forward in our group up to the afternoon time. Yes, you have to listen the class and afterwards try to answer that practice bits in your running notes. Remaining concepts we have to discuss in the next class. Thank you so much.